So welcome to this tutorial on using Docker for reproducible data analysis in R. So over the last 10 or 20 years, there's been a huge movement to improve the credibility of psychological science. And a lot of this discussion is focused on the ways that researchers abuse their data and data collection methods to generate spuriously significant results. However, one overlooked aspect of doing science that's reproducible is the ability to simply reproduce the same research outputs using materials from a past study. In this workshop, we're going to focus on some tools we can use to make our analyses using R more reproducible by controlling the computing environment. So this is primarily a problem for users of programming languages such as R and Python. So in the past, if you ran your analysis on a specific version of the software such as SPSS, you could be pretty sure that your SPSS syntax would generate the same results across different computers. And this is because all the inner workings of the program SPSS are relatively self-contained. And the same is apparently also true for Stata, which has very strong version control mechanisms. And this is a reason why software packages such as Stata and SPSS remain quite popular in various industries, as they're quite reliable software packages. In psychology, the programming languages R and Python are increasingly popular for running experiments, data cleaning, and analysis. And one of the main benefits of these programming languages is that they are free and open source. So many people around the world are contributing new packages that are adding additional functionality to these languages. But most users of R and Python are not solely relying on the base programming languages, but we're also using lots of functions that are imported from other software packages. So if you use the R command session info, you can see lots of information about your current R session. And here we can see that even though we are using a specific version of R, version 4.3.0, we have over 90 R packages loaded. And each R package has its own kind of version that can change and be updated at any time. We're also relying on these other kind of software packages called BLAST and LPACK for doing some of the underlying mathematical operations. So R itself is quite a complex kind of ecosystem of different software packages interacting with each other. And even if we use a specific R function from a specific R package, that R function might be relying on lots of other R functions from other R packages. So changing an R package, which is apparently unrelated to what you're doing, might influence another R function in your code. So the key problem here is that R scripts may not reproduce the same outputs on different systems because your R script depends on a huge amount of other things, such as different R packages, different R versions that can alter how they work. So changes to any of the following may alter your code, such as changing your R package versions, such as updating them or removing an R package, changing the R version of R you're using. If you're working on a different computer or operating system for some of your analyses, that might change how your code runs. And there's also lots of other dependencies outside of R that are really important, such as C compilers. A lot of R code is actually written in a different programming language called C. And if you change the C compiler, that might kind of influence your results in some way. But also kind of there's some more basic things, such as fonts and Pandoc might influence how your R code works. But it's also the case that for different projects that we're working on, we might want different versions of R or different R packages and different dependencies. So what we ideally need is a way of managing all these kind of dependencies, these different R packages, these different R versions, so that potentially in different projects we can have different kind of computing environments that simultaneously work together in a different way. So why use Docker? So this is primarily for your benefit, so you can have far more confidence that your code will run in the same way across different computers and different operating systems, or even in the cloud or when you use computing clusters. And this can lead to far less stress today, so potentially you're worried if you're kind of working to multiple projects at the same time, you might be stressed about kind of making any changes, such as installing a new R package for one of your projects where they'll influence your work on a different project. By using Docker, we can separate our computing environments and manage them, so we're kind of less worried about that. But importantly, this might be less stress for you in the future. So let's say that we're working on a project now, But in 2 or 3 years' time, a reviewer might ask you to make some changes to your kind of data processing or data analysis. By using Docker, you can essentially go back in time in your computer and essentially get a version of your computer from 2 years previously kind of up and running, and you can run your analyses as if it was kind of 2 years previously. However, there are also some potentially wider benefits to using kind of Docker and having a more kind of reproducible computing environment, in that it might reduce the risk of errors in your published work, and it also might make it easier for others to use your code. So managing your computing environment using Docker and other technologies is kind of one part of having reproducible code. But another part is also just having your code written in a way so that it's less prone to errors. And this isn't the focus of today's talk, but one thing I'd recommend you to use is R projects, as well as things like version control, kind of tests, and I've got kind of various links to different websites where you can see kind of additional advice on how to write better R code. So one kind of simpler alternative to using Docker is to use something called renv. Renv is an R package that is managed by the RStudio team. And what it does, it creates a record of all the different R package versions you have installed within a different R project. So it creates something here called a lock file, which is a JSON file, and it basically records things like the version of R you're using, and all the different versions of R packages you're using and where they were installed from. And it also provides functionality for kind of winding your project back in time to a previous state. It has functionality for others to install, to download your lock file, then install all the same R packages that you were using, and various different things. However, renv has some downsides. For example, it doesn't save any dependencies outside of R. So these are things like C compilers, mathematical libraries, pandoc, and kind of other things. It also doesn't reinstall the same version of R that you were using. So this is something that you have to do manually and change it for different R packages, different R projects that you're working on. And it also assumes that packages will remain available to download from the same locations, such as CRAN. But it might be the case that if a package is removed, you won't be able to install it again, and then the renv will kind of stop working. And the main reason why I haven't really used renv much is because I often work on a Windows computer and a Mac computer, and renv doesn't really work very well in that kind of situation, because it often, if you start a project using Windows and try to continue it on a Mac, it often fails to download the same R packages, because some R packages don't seem to work on both Windows and Mac. And then it'll just kind of throw an error and not really work at all. So that's one of the reasons why I don't really use renv. But it's a good option, and it's a little bit more straightforward than Docker. So the way Docker works is a little bit like a virtual computer. So one example of a virtual computer is kind of an N64 emulator. So the Nintendo 64 is a game console that came out in the 90s or early noughties. And the way that kind of Nintendo 64 emulators work on Windows is that it's basically a program which emulates the hardware of a Nintendo 64 within your computer using software. And then games that were designed to run on the N64 can run within this virtual computer, this virtual N64 on your computer, as if it was a real N64. So you've basically got a virtual game console in your computer, which is running the games. And Docker kind of works in a similar process. So we can run our RStudio within a Docker container, and Docker containers work like a virtual computer, which contains everything needed to run our analyses. And this includes an operating system, RStudio, R, different R packages, and other low-level dependencies. However, unlike traditional virtual computers, Docker containers are very fast and have very little overhead. So the reason why we only have things like N64 emulators is because the N64 is a very old bit of hardware, and it's very easy for modern computers to emulate this. Because traditionally, kind of having a virtual computer is quite a hardware-intensive activity. But in contrast, Docker containers work relatively efficiently, so you shouldn't see a big hit to performance if you run your analysis natively on your computer using RStudio or within running your R scripts within a Docker container. So our analyses are running within a Docker container, and Docker containers are created from something called a Docker image. And you can think of a Docker image as being like the blueprint that we use to create the Docker container. So Docker images are the saved static versions of containers that we can create new images from. So that should say images. And we can find Docker images that come pre-installed of Linux, RStudio, and other R packages that are useful. So the general process of how this works is that we download a Docker image from the internet, often one which comes already pre-installed with RStudio. We run that as a Docker container on our computer. Then we can make some changes to the Docker container, such as downloading all the packages that we need to use for the analysis. And then we can save that Docker container back into a new Docker image that we can then kind of preserve for the future. And we can share Docker images online on a website called dockerhub, or you can save them locally on your computer for later use. So I've touched upon this, but where do Docker images come from? Well, the easiest place to find Docker images is from a website called dockerhub. For our users, there's a project called the Rocker project, which has various different Docker images already kind of made that are useful for different applications. But you can also create your own Docker images from scratch using something called a Dockerfile, which isn't something I'm going to cover today. It's a slightly more advanced topic, and I don't think it's actually very necessary for having the basic usage of Docker. One thing that's worth bearing in mind is that modern kind of computers run on two different architectures. So most Windows computers will run on Intel chips, otherwise known as AMD 64 chips. However, kind of modern MacBooks, if you have a MacBook that's called an M1 chip or an M2 chip, these run on a different computing architecture called ARM, or ARM64. It's quite rare to have Windows computers that run on ARM currently, but there is kind of Windows on ARM, but it's very niche. So if you're using Windows, you're more likely than not having an Intel chip. If you have a modern MacBook, you probably have an ARM chip. And this distinction is quite important because Docker images are created for either one or the other. So if you have a Mac, it's relatively easy to run Intel Docker images using something called Rosetta, so it kind of translates the Intel Docker image into an ARM Docker image. However, if you're on Windows or Linux, you're mostly stuck with using Intel Docker images, and it's harder to run ARM Docker images on your computer. Well, at least I'm not aware of a way you can do that. So the process for installing Docker on Windows and Mac is a little bit, can be a little bit complicated. I'm going to go into more detail about how this works. For Macs, it's relatively straightforward. First, you can install something called Rosetta, and this allows you to run Intel images, Docker images, but this is optional. You can run kind of AMD, so you can run ARM images natively without Rosetta. So if you search kind of install Docker, for Mac, it's relatively straightforward. So if you have an Apple Silicon chip, you can click this link here. If you have an Intel chip, you can click this link here. If you're not sure what kind of Mac you have, click on the Apple logo here and then click About Mac. And here it says that my chip is Apple M2. So this means that I've got an ARM chip on my computer. But if it said Intel something, that means you should install a version for Intel chip. For Windows, it's a bit more complicated. I'm going to cover that at the end. But basically for Windows, you have to install something called the Windows subsystem for Linux, and then Docker runs within that. So once you have it running, you'll be running your analyses within an internet browser. And the internet browser connects to your Docker container using this kind of link up here. And the Docker container is running something called RStudio server. So by default, this RStudio server container is set up so only you can access it locally in your computer, and it's not set up so other people on the internet can access your Docker container, unless you actively go through the settings and change a bunch of things for that to work. But otherwise, this will work. This has exactly the same functionality as RStudio Desktop, but yeah, it's running in a browser. It's slightly different. So there are some downsides of Docker. So each image you install uses up around 1 to 8 gigabytes of storage, and that can be a problem, especially if you're on a Mac where kind of getting more storage costs an arm and a leg. Using Docker requires learning to use the terminal a little bit, whether you can use some Docker and Linux commands. Docker containers run using kind of the Linux operating system, so then you have to learn a little bit of Linux. Although kind of ChatGPT makes this step very, much more straightforward than it used to be at least. You can do some Docker commands in a GUI in the Docker app, but you're slightly more limited in what you can do. So all the examples I'm going to give, or most of the examples I'm going to give, are going to use the terminal to do Docker commands. Sometimes with Docker, you can also get some weird bugs, and some weird things can happen. I don't think this is going to more likely to happen if you're using Docker relative to using RStudio desktop, but it is something I've had in the past where some Docker containers just haven't really worked, and the main solution has just been to reinstall a newer Docker container and then run. So reinstall a new Docker image and then run a new container, and that generally tends to fix things. And again, one downside of Docker is that this kind of issue of there being kind of Intel chips and ARM chips. Most of the Docker containers for R are designed for Intel chips, at least from the Rocker project, but they do also release some Docker images for ARM chips. So you just have to be careful about which ones you select. But that being said, if you are on a Mac, it is very easy to run Docker images for Intel chips as well. And they just run a little bit slower because there's a translation layer where it's translating the Intel commands into ARM commands. But it actually has worked pretty well in my experience. On the Windows side of things, there is a bit of added complexity as well, in that you have to use the Windows subsystem for Linux to run Docker. So the rest of the workshop, we're going to go into the practicalities of how to install Docker, where to find Docker images, how to pull them from the internet, how to run them, and then we're going to look about how we can save our changes to our Docker containers back into a new image. So Docker images can be downloaded from a website called dockerhub. It's worth creating an account to dockerhub, although you won't need to do that for the tutorial here. We're going to go through how to browse for Docker images, how to install them, and how to pull them, and how to work with them today. So let's go on the website and start the practical side of this tutorial. This is the website dockerhub, and this is the kind of link to the website. Let's see if I can increase the size a bit. All the Docker images that we're going to use for R come from a project called the Rocker project. So we search Rocker project, that has its own website. And this is the kind of Rocker team. So for RStudio Docker images, there have a number of options we can choose from the Rocker project. The most simple image that they have is one called rocker_r version. But then they have more complicated Docker images that come with more things pre-installed. So this one image here comes with an RStudio server pre-installed. This image here comes with tidyverse packages pre-installed. And this image over here comes with Shiny server stuff pre-installed. So today, because I'm working on a Mac to begin with, we're going to click on, we're going to use this Docker image over here, which only comes with RStudio pre-installed, as well as kind of a basic operating system. So to find this Docker image, let's go to dockerhub and type in Rocker, and I'll open this in a new tab. Now this is the website for this particular image. So Rocker is the name of the project, or the people who created the image, and RStudio is the name of this particular image. However, within this image, lots of different versions of this. So here, for example, we can see the latest version, which comes with the latest version of R. But you can also find previous versions of this image, which come with older versions of R. So we can see here that for some of these images, they come with both an AMD, which is Intel, and an ARM version, which is a Mac version. Well, not quite a Mac version, but you know what I mean. So we want to, because I'm working on a Mac, I'm going to install a Docker image which has a Mac version. And here we can see not all of them do. If we go to these older ones. So to install this, or to download this Docker image, I'm going to copy and paste I think 4.32 seems to be the latest version from 7 days ago. I'm going to copy and paste this, and we're going to open the terminal. Let me just delete the previous stuff. And firstly, let's check that Docker's been installed properly. So by typing the Docker command, we should have this appear. If this doesn't appear, then Docker hasn't installed properly, and you should go through all the instructions to do that. And I'm going to copy and paste this and click enter. And now we're downloading this particular Docker image from the internet. You can see it's going to take a little bit of time. I've created a note, a list of useful commands here, which I'm going to provide in the YouTube chat description, the YouTube description section, where you can copy and paste these commands from here. So in fact, I'll also install this version, if it works, and install that. Okay, we would have that installed. That's version 4. Perfect. So to check it's installed properly, we'll use the command docker images. And here we can see that we have 2 different Docker images installed. I think, in fact, these are the same Docker image, but have slightly different tags. If I want to install an older version of a Docker image, I can just do the same thing. So let's go back to the website, and let's install a slightly older version. Oh, that's not available for ARM. This one is available for ARM. And then we'll copy and paste it here. And again, it's going to download it from the internet. And then when we run the Docker images command again, we should see an additional Docker image appear there. So while that's running, I'm going to show you how to download a Docker image that was designed for Intel chips on a Mac. So let's say I want to download, let's go back to the Rocket project. Let's say I want to download this image over here, which has a bunch of tidyverse packages pre-installed. And there isn't a version here for ARM chips. It just says AMD, which is Intel. So to install this, we're going to use a command. I should really have everything prepared here. So I'm a bit confused. So this is finished. Let's run it over here. So again, we're using the command docker pull. We're telling R to install the AMD platform version, so the Intel version of this Docker image. If we don't type in this bit of code here, we'll generally get an error message saying this Docker image is not designed for your computer, or something along those lines. Let's have actually have a go just to show what it'll say. Sorry, I want a new tab. And make it bigger. So if we don't include this, we'll get an error message. Oh, seemed to work. Oh, here we go. It says no matching manifest for Linux, ARM, 64, V8 in the manifest list entries. And that's because we're trying to pull a Docker image that's designed for Intel. And to do that, we have to use this command over here. So just to reiterate what this command does, firstly, Docker is the name of the program. Pull means that we're kind of downloading a new Docker image. And this is the name of the Docker image that we're trying to download. And if you want to download a specific version of this image, we can add a specific tag. So for example, if there's a version 4.3.2, we'd add this tag afterwards. Okay, so let's check everything has been installed. So we can either type in docker images or docker image ls. Both seem to work in a similar way. And here we can see that we have one image that's called rocker_tidyverse. Latest, and then these are different kind of versions of the image for the Rocker RStudio. So to run an image, we're going to use this command over here, and I'll break it down step by step. But it's definitely worth copying and pasting this command, because if you try manually typing it out, you'll probably make a mistake, and that won't be very fun because it won't work, and it'll be all very confusing. So, Docker is the first part of this command. It's obviously the name of the program we're using. Run is the command for running a Docker image, and when we run the Docker image, it'll become a Docker container with RStudio running. Don't worry what these two commands mean for now. The RStudio server that we're going to be running in our container will come with a password. And by default, I'm just going to call this your password. The choice for password here isn't too important because we're just running our container locally on our computer. So someone would have to hack into our computer to access this container anyway. So the password's not too important, assuming that your computer has its own password. This command here is giving our Docker container a name. And here we're just going to call it my first Docker container. So Docker containers have their own file systems. The files in there won't be the same files on your computer. When we run our Docker container, we want to link our computer's file system to our Docker container's file system. And to do that, you'll need to change this bit of code to link your file system to the Docker's file system. A good way of doing that is by actually going to Docker Desktop and click on Images, and then click the play button here. Then click on Optional Settings and go to Volumes, Host Path. Then click on here, and just click on anything. So I'm going to go to Giacomo Open. Here I can see the path on my local computer. And in general, you want to give it a path so your Docker container can access everything on your computer. Well, there's different approaches here. You could either give it a path to a specific R project, or you could give it a path to kind of, in this case, I'm going to give it a path so everything on my computer is linked to this Docker container. So now this Docker container, when it's been run, can see everything that's within this folder called Jacko, which I think is pretty much everything on my computer. So you can ignore this for now. This command, this basically just tells the container to run on a specific port. But that's not really important to know. And the important thing at the end of this command is this bit here, which is telling our which Docker image we want to run into a container. So here we're going to run the Docker container rocker_RStudio. And we have that installed. And by default, I don't know which one of these it'll select, but let's say I want to run a specific version of this container. Let's say I want to run the older version of this container. We can tell it by using the colon. And let's say I want to run version 4.3.0. Now let's run that. So we're going to get some scary messages on the screen. We can ignore these. This is all kind of seems to be working fine. I should say at any point if you're confused what's kind of happening on the screen, you can just copy and paste the code and give it to ChatGPT, and I'll kind of give a decent explanation of what's going on. But one thing to note now is that we can't type in any more commands into this terminal window. So we'll have to go to a new terminal window for doing any additional commands. So now this Docker container is running. We can check that it's running fine by using the command docker ps. And now this lists all of the Docker containers that are running. So remember that a Docker container is a version of an image which is actually being used currently, or that's active. And here we can see that we have a Docker container called my first container. And now we can connect to it using a web browser. So in this case, I'm using Edge, but you can use Chrome or whatever you like, and type in the link localhost : 8787, and then click enter. Then you should see in your browser your Docker container, your RStudio server instance. And we can log into it. So the default username is RStudio, and the password will be whatever you typed in as the password over here. So in this case, the password is your password. And now we can log into the container. And now we're interacting with the Docker container through a browser. So I should probably close all of this. We now have all the kind of basic RStudio functions. Do I want to save this? No, I don't need that. I don't need this. Okay. So now we can just interact with this as we would with any other computer, with any other version of RStudio. All our files are here on the right. We can see kind of everything there. It should all work as fine as usual. So let's say now that we've run a Docker container and we've done some analyses, potentially we've installed some new R packages, and now we want to save this Docker container back into a Docker image. Well, the way we do that is by using the commit command. So let's copy and paste this command over here. Put it over here. So where it says container ID, so I'm using the arrows to go back and edit this. We can delete that. I'm going to type in the name of our container. So in this case, it's my first container. You can also enter this container ID over here and do the same thing. And the next line of code, or the next bit of text, is the name of the new Docker image that we're going to create. So in this case, I'm going to call this Docker image BigNardyG, because that's the name of my dockerhub account. And it's worth creating an account on the website dockerhub, so you can do the same thing. Then I'm going to do /, backslash. Is that a backslash or a /? I think it's a /. Now we're going to enter in the name of the Docker image. So I'm going to call this project, or project dissertation project version 1. And now if we type in the command docker images, we can see that our Docker container has been saved back into a Docker image, and now we can share this Docker image with other people if we want to. And I'll provide a guide at the bottom which kind of explains in more detail how you might do that. But for now, we're just kind of focusing on the basic commands. So, text edit. What else do we need to do? So at a certain point, you might find that you run into problems installing R packages. Okay, so you've tried to install this package called Haven, and to install this package, it needs to install a bunch of other packages, and somewhere along the line, we've had an error message which says that it failed to find something called the zlib library. And this is something that's installed to our operating system, so you can't install it using our Studio server. We have to connect directly to the Docker container and kind of install stuff on the Docker container directly. So to do that, let's start from scratch. Let's go to a new terminal window. We'll type in docker ps, and this lists any active Docker containers we have. And then we're going to use this command over here. No, we're going to use this command over here. And this allows us to execute Linux commands within our Docker container. So we're going to change the name docker_id to my first container. Alternatively, you can enter this ID over here. So just remember, if you want to edit commands in the terminal, you have to use the arrow keys to go back and delete text and then edit text. So now, if we enter this line of code, this bit over here should say root, and now we're within our Docker container, and we can type in kind of Linux commands. So you don't have to be a Linux expert. I don't really know much Linux myself, except some kind of basic commands such as ls, which lists all the files we've got. But there are some commands that are worth kind of memorizing or just having hand to hand. So to install a new piece of software in our Docker container, we first type in the command sudo apt-get update. So apt-get updates just tells the container what new versions of software libraries are available. Now, from the looks of it, we're missing something called zlib. So if we want to install zlib, we generally use the command apt-get install. So we could copy and paste this whole command here, and it'll install all these different software libraries that are useful for R packages, or sometimes needed for R packages to work. But for now, I'm going to install a specific library. So let's go to here. We'll type in sudo apt-get install. And from the sounds of it, we're missing zlib. zlib here. So, because we're using Ubuntu, I think we can copy and paste this. I'll add it to here, if it's not here already. Zlib. No. Okay. But for now, we'll just install this library. Did it work? I think it worked. One newly installed. If we type in the command again, yeah, that seems to have worked fine. So let's get back to RStudio and try installing this R package again and see if we get the same error message. And again, this may take a while, so we're going to jump forward in time and see if it's worked. Yeah, oh, I didn't have to jump forward at all, that worked fine. So in general, there are a bunch of things that you probably should have on your Docker container pre-installed that will prevent you having to go keep kind of installing specific packages. So I'd recommend pre-installing all these different things, which can be useful. So all these different R packages. So we can just copy and paste this command and put it here. And now it's going to go for each one and install them to our Docker container. So if we type in the command again, it's probably going to say something like everything's already installed, newest version, it's all fine. So this is just something to bear in mind. So sometimes when you get into trouble or when you fail to install an R package successfully, it's often because you're missing something that should be installed in your Docker container. So one thing that can be useful is copying and pasting the error code and putting it into ChatGPT, and ChatGPT will say, well, you need to install this thing for your Docker container. And in fact, so I'm going to open ChatGPT now. So let's say I need to find out what version of Linux am I running. How do I find out on terminal? This is worded terribly, but it should work. So while we're running our Docker, whilst we're in our Docker container here, if we type in this command, we can see that we're running Ubuntu version 22, 0.43 LTS. So again, here we're running commands within our Docker container. If we open another kind of terminal, here we can see that we're running, again, commands on our computer. So this is the computer, because it's Jacko, and this is our Docker container, because it says root. So again now, let's say we've installed some R packages, we've done some analyses, and now we want to save our Docker container back into a newer version of our Docker image. Oh, sorry, I'm running that command in the wrong place. So here we can see that it says Docker command not found. And the reason why we're getting that error message is because within our Docker container, that Docker container is not running Docker itself. It's not some sort of kind of Russian doll situation. Docker is only running on our computer. So here, let's type in Docker images. And let's say we want to save on our Docker container into a version 2 of this particular image here. So let's go to our code. Docker commit is the code you want to save a Docker container that we're currently running into an image. We'll change this. Let's delete this all. So to delete things, you can't, in general, highlight and delete. You need to just go the old-fashioned way and mash delete lots of times. Okay, so our container that we're running now is called, it's called my first Docker container. So Docker PS, my first container. So my first container. And then, misspelled that. Then we're going to save it as, and just to avoid any misspellings, it's best to copy and paste. We're going to save it using the same image name, but just use a new tag. And if we type in Docker images, we can see now that we have this new version of the image saved. And we can see that it's slightly bigger in file size because we've installed a bunch of things on it. So these are the basic commands. I'd really recommend, if you want to learn more, to go on the website, search our Docker tutorial, open Scilabs. Should be this website here. And this has got a very good tutorial kind of covering some of the same things, but just going into a bit more detail and in text format. So from day to day, the way I generally work with Docker containers is that when I'm done using them for the day, I'll just press stop here. And when I want to start my analysis back up again, I'll just press play or start, and the Docker container will be start again. If you're working on multiple projects, what you can do is create different Docker containers, different Docker containers for different projects that you're working on, so everything stays separate. So to create a different Docker container, we'll just copy and paste this code. And what we'll change, so you can use a different image if you want. So we can actually reuse it. Let's say I'm going to start a different project, but I want to use an image that I've already worked on before. What I would do is just select this image that I've used before. You could specify we're using version 2. But I'll change the name of the Docker container. And I'll type in my second Docker project. And now if we go back to the Docker app, and if you get this message, just click OK. Now we can see in the Containers tab here, we have 2 Docker images running. And if I want to work on this project, maybe I will kind of have this project going, so we have to restart this and log back into it. Or sometimes it'll already be logged in, that's fine. What was I doing? Oh yeah, so this is one of our Docker containers, I'm doing blah blah blah. Type in some stuff, that doesn't really make any sense. Work in this Docker container. If I want to go back to working on a different Docker project, I'll pause this and then start as the Docker project. One thing you'll find is that when you switch between different Docker containers, the same kind of R projects that you're using are going to be loading back up. And this is because on your local file system, R basically saves some files which says when R turns on, load this R project and these particular files. So you'll find even if you switch between different Docker containers, you might have the same R projects that are loaded, and that's fine, and that's kind of normal. One important thing to note is that there's the relationship between your file system, your Docker containers, and your Docker images. So when we run our Docker containers, we use this command here, where we tell the Docker container to read all the files in this particular folder on our computer. However, in our Docker containers, the files that are here aren't saved to the container or to the image. So that means when you share your image with other people, any files that are within this folder here on my local file system aren't going to be shared with that Docker image. However, if I was to create a file, so what have I got running now? My first container. If I was to log into this Docker container using the command that we had earlier, so blah, 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 where is the command? If we were to go into this Docker container using this command here, my first container, okay. So if I was to create a file here, let's say hello, nano's not found, so let's install this, apt-get install nano. I think that worked. Nano, hello, and let's say yo, then exit. Ooh, did I do that wrong? I think I pressed the wrong command. Exit, yes, save. So I've saved this file here, And this has been saved to the Docker container. So now if I share this Docker container, or if I save this Docker container as an image and I share that image, they will find this hello.txt file within the Docker container. So this is something to be aware of if you're working with sensitive data. You don't necessarily want to share Docker containers that have any of your sensitive data with other people. So the way to get around that is to basically not save stuff directly to your Docker container, but just to keep stuff on your file system and then link your file system to the Docker container when you run your Docker container. So we're going to keep stuff in our own local file system. So now let's get on to how we can share our Docker images with other people. So to share our Docker images, firstly we need to have the image, so we have to commit our Docker container to an image. And once we've done that, we should see that all our Docker images are listed over here. And there are multiple different options for sharing a Docker image. The simplest one is to save it locally in your computer. So to do that, to be honest, I don't actually know how you do that off the top of my head. So let's just Google that. So Docker save image locally. And we use the save command. So let's copy and paste this. Docker image save. So one option is that you can save your image into a tar.gz file using gzip. And this just makes the file smaller. Let's start with the simplest option. So let's Docker save. And let's say I want to save this image here. But I imagine for this to work, I'll now just create a name of the image on my computer. So we're going to save this image to a file on our computer, and let's just call it saved docker image.tar. And now if we click enter, this can take a little bit of time to run. But if I navigate to, let's kind of give that a few minutes. Okay, so now if we have a look, it seems to be saved in our home directory. So if I navigate to Finder and I type in file, sorry, I'm not a Mac person, so I don't really remember how do you get to the home directory. Go home. Here we can see that our tar file is saved here. So type go to the file, we go to Finder rather, so I have the Finder window open, then click go, then I've clicked home, and here we can see our saved Docker image. If we want to make this Docker image smaller, we can save it as a gzip file. So we go back to these instructions here, and we run this, but I'm going to save, we're going to change this. Copy and paste this. This is the name of our Docker image. And run that. It's now going to save the Docker image as a tar file, but then it's going to compress the tar file using gzip. So if you don't have gzip installed on your Mac, then this might not run. So you can install that first and then give it a go. To install Docker on Windows, there are a few additional steps, and I recommend kind of Googling how to install Docker on Windows and going through the instructions very carefully. It involves installing something called the Windows subsystem for Linux, and once you've installed this, you should have a version of Linux on your computer. So here, for example, I've installed Ubuntu. If I can open it up. Nope, don't want YouTube. Here we go. And if you've successfully installed Ubuntu, you should see kind of a welcome message like this. And if Docker has been successfully installed, if you type in Docker over here, you should see all the kind of Docker commands listed on this welcome page. Docker also, I think, works with Windows PowerShell. So if you type in Docker here, you should see the same commands appear. But I generally tend to use the Ubuntu terminal on Windows. And all the same kind of Docker commands will work. So type in Docker images, we see all the kind of listed images that I'm using. Docker PS A, these are all the kind of paused containers that I have, and so on. So all of this works in pretty much the same way as it would work on a Mac or on a Linux machine. So the main difference between running Docker in Windows versus Mac or Linux is that on Windows we have 3 different file systems to worry about. We have the one that we're used to in our File Explorer, we can see all our kind of files on our Windows machine, but there's also a separate file system for the Windows subsystem for Linux. And thirdly, there's a separate file system for each of our Docker containers. So our Docker containers run within the Windows system for Linux, and the Windows subsystem for Linux runs kind of within Windows. So it's a bit of a kind of a nested Russian doll situation here. So when we run our Docker container, we need to tell Docker to look for files within our Windows file system. So in general here, I've got a C drive on this particular computer, but if I enter this bit of text here, it will tell Docker to look for folders within the C drive within our Windows file system. So let's give that a go. So let's clear this, type in Docker images, and let's say I want to run this kind of Docker tidyverse image on my computer. Let's copy and paste this bit of code over here. Oops. Copy and paste this bit of code. Copy, put it into here. It's not what I wanted. So let's copy and paste this bit of code. Copy and paste it. So I don't here have an image called rocker_RStudio. Oh, sorry, I do. But let's say I want to change this. I want to run a different image, such as rocker tidyverse. I'm going to change that bit here. So this bit here is the kind of image that we want to run. We don't change the port. That stays the same. But what I will need to change is this bit of code over here. So if I look into my file system, so if I go to this PC, I can see that I have a C drive. If I open that, we can see all the different folders inside here. And let's just tell Docker that we want to have this Docker container connected to the user folder within the C drive. So to do that, we'll type in mnt, and then here we'll type in lowercase c for the C drive, and then I'll type in users. Again, that's correct. I will just delete the Jacko. Or rather, I'll see what my username is on here. Oh, it's Jacko, same thing. So let's run this. Type in enter. And that seems to have worked okay. And again, in Windows, we'll go to a browser and type in localhost 8787. One thing to try if this doesn't seem to work is to try using a different browser, such as Chrome or Firefox. And generally, Firefox seems to lead to the less issues of opening Docker containers. I've sometimes had issues, I think, on a specific browser that I can't remember. Invalid password. So I typed in RStudio as the username, and the password should be what I entered here, which is your password. Keep typing my password. Your password. And again, this Docker container should run in pretty much the same way as it did on the Mac. And every other step is exactly the same. So over here, if I want to access this Docker container. Let's use the PowerShell just for fun. I'll type in docker ps. Then here I'll type in docker exec it. This time I'll copy and paste my first container. I'll just type it my first container and bash. And here again we can execute Linux commands within the container, such as apt get update. Perfect. And everything else will just run exactly the same way as it did on our Mac tutorial. So go back to the video and have a look at the Mac tutorial and see how things work there. So to summarize in this tutorial, we looked at how we can download Docker images from dockerhub using the docker pull command. We looked at how we can list all our Docker images that are installed and how to list any running Docker containers. We ran through how to run a Docker container on Macs and on Windows. We looked at how we can save Docker images locally on our computer so we can save them for later or share them with others. And we also looked at how we can execute commands within the container using Linux.